Okay, so this is lesson number two in the meditate science. So first video, we've learned this journey from curiosity to wonder, from questions to spirituality, to stand under nature. This is what we mentioned in the first video, and we quoted from Vedic wisdom some of the ideas. These conceptual maps that were written are, like I said, thousands of years ago in the Patanjali Yoga Sutras and the Ashtavakra Gita. So let's look at the biggest concept in physics. Physics has five fields mainly. We could classify the different fields in physics into five different categories. The categories that have to do with the earth, which is mechanics, mechanical energy, bodies, forces, motion, kinetic energy, that has to do with the element earth, hydraulics with the liquids, water, hydraulics in physics, the study of gases, the gas laws, with air, the study of heat, of course, with fire, heat, thermodynamics, all the science of how heat is being transferred, how it creates the winds, the currents, and of course, space. Everything that happens in space, that means everything that happens in the realm of electrons and other fundamental particles. So fundamental particles has to do with space, because space would be that from where everything manifests. The rishis called this element also Brahma, something like that. You know? There is an omnipresent space from where matter pops out into existence. So, yeah, the standard model of particle physics, electromagnetism, astrophysics, relativity. Space is something that is quite mysterious. It is not empty. It is the opposite of empty. Space is very dynamic. We have electromagnetic fields oscillating in space. We have photons of energy traveling at the speed of light through space, neutrinos, all kinds of particles. And that element is connected to those fields in physics. So we look at it as electromagnetism first. Okay. So how do we continue? We continue with the concept of energy. Energy, work, and power. See? Energy, work, and power. Again, the sun, the water, the air, space, earth, body-mind system, energy coming into us, and we can work. To work we use energy, and to understand the concept of energy, we need to think of two things that need to manifest at the same time, two concepts that I would say are complementary, the concept of variable and the concept of potential difference. Something moves, something pushes. This is what moves. This is what pushes. And one manifests with the other. When there is something that could move, an asymmetry appears that makes this push, so that energy, which is the exact literal meaning of energy, is in motion, and ergos, it's a Greek word. So motion happens. So let's start from an easy one. An apple hanging from a tree on earth, right? So what moves is this. This is what we call the mass of the apple. Or if you want the weight also, it could be that weight of the apple. Let's say 1 Newton is 1 apple. So we could define a variable of 1 Newton. a weight of 1 Newton. Right? That means a body of 1 kilogram hanging at Earth gravitational field is 10 Newtons. So 1 apple is 100 grams, more or less 1 Newton. So what pushes that apple? The difference in height, no doubt. The apple falls not because there is gravity, but because there is height difference. So asymmetry with what we call the gravitational field is what makes a body fall in space-time. Water. When water moves, we could think of an amount of water, let's say a volume of water, 1 liter of water, right? This is a ball of a liter of water, which is 1 kilo also, right? This water is moving because there are differences of temperature or difference of pressure. These are the two variables that could move water. An asymmetry in pressure or an asymmetry in temperature, because convectional currents happen because of a difference of temperature. And the flow of blood in our body happens because of the difference of pressure. So these two could push water. Fire, well, heat is coming from the sun to the earth, and this is energy that we measure in joules. Heat is coming from the sun to the earth because there is asymmetry that we call temperature. So this is an important concept. Temperature is not the same as energy. Energy is heat. Temperature is what pushes that heat. It's potential difference. So this is change of temperature, and this is heat. Whatever you want to think heat is, this is the big mystery. Light. What is light made up of? You know, we've imagined a model with waves, and now we are learning that the model was not complete. So it was actually photons, particles of energy, quantums of energy being pushed from the sun to the earth. Why? Only because the surface of the sun, is at a higher temperature than the earth. So we did water, earth, fire, air. A volume of air moves in and out of our body because of a difference of pressure. Pressure creates the winds, right? Atmospheric pressure. Cyclones, anticyclones. This is something we study a lot in geography to understand the weather. And in space, when we're thinking of a charge, okay, we could imagine a positive charge, but it was not the right picture. Actually, the right picture is a charge of an electron, whatever that is also. An electron is a very strange fellow. But we'll study the electron in detail. But imagine a charge of an electron. Why does an electron move in space? Why would a wire conduct electricity? Why does lightning happen? There is a difference of electric potential, voltage. So voltage pushes charges. Temperature, pressure pushes air. Temperature pushes fire. Pressure pushes water. Gravitational potential pushes bodies, masses, from high to low potential. Once we understand all these concepts, then we can find, or we can discover, these laws are not invented, they are discovered. That means they have been in nature, but they were covered to our understanding, and now we are discovering. So, for example, electric energy is equal to charge and voltage. The energy in the air, this is known as Joule's law. Electric energy in air, aeolic energy in air is equal to pressure and volume. A volume that is being pushed from high to low pressure is exerting energy as a system. This is called Boyle's law. Tejo. Well, there are many laws here for the flow of energy, which is proportional to the difference of temperature, and this constant of proportionality is a big mystery. This was Newton's law. Newton had this model, which is not a good one. It's a very primitive one, If you go deeper and deeper into the nature of heat energy, it's very difficult to find that constant of linearity. It's not so linear. And gravitational potential energy, let's put it like this. Gravitational potential energy is the mass at a difference of gravitational potential. This is a universal law, true for any planet, any star, anything that exists and has mass in the universe. Follow this law. The potential energy is proportional to the difference of gravitational potential, and that constant of proportionality is what we call mass. And this is connected, of course, to the principle of inertia. We will study this effect of nature in depth. What is inertia? This is really something to ponder on. What is inertia? This is a principle that Newton, again, discovered in nature. Okay. So again, we go back to the picture, the body, the mind, system surrounded by the elements of nature. And we take a minute, I would say 10 minutes, to ponder on this, meditate. Meditate on energy. What is energy? And what pushes the energy in and out of our bodies? And also what pushes the energy inside our bodies? Why do we have electric currents in the nervous system? Why do we feel heat coming in or out of our bodies? What pushes that heat? What pushes the blood? What pushes the air? So take a few minutes to meditate on the concept of energy and work. Next video we'll do power. Let's do energy fair. There you go. So these are the laws, these are the equations. See? We're looking at all the equations in physics together under one concept. Amazing. The amazing thing is that it makes sense. And here, instead of formulas, okay, this is power. And power is the same, similar to energy, but it's energy in time. That's why we say power is rate of work. So it's energy used in time, it's joules per second. That's a concept of power, rate of work. So again, this is called electric power. We'll study transformers to understand systems that transform electricity, electric energy. Aeolic power, we can study wind blades, airfoils, systems that transform the power in the air. Solar power, solar panels, solar heaters. Hydraulic power, mechanical power, any machine that uses, mechanical parts, is force, velocity here, pressure and flow here. Okay, there you go with the equations. Pressure and flow, force, velocity. These are the formulas for power, voltage and current, something pushing, and the flow, the actual flow of that power. Okay, so two important concepts to introduce physics, and with physics, the whole of science. Because energy is in the core of chemistry, in the core of biology. Energy is one of the biggest concepts in science. I leave this to you. Good luck. Pause the video and think about what is a variable, what is a potential difference, what words would you put here, what laws would you put here, or what words, if you can't remember the laws. But the laws are so easy. It's this times this, and then this times this divided by. There is only one law in nature. I give you the law and then I erase it. Power in watts is whatever the potential is, in whatever unit it is, times the variable divided by time in seconds. So this is the only law that you need to know in all the systems of nature. If this is not a wow to you, well, it is to me. So, wow. Wow. You know what? It is amazing that nature makes sense